and welcome to the part 3 of our Python Pandas basic series. In this video we will continue working with the same dataset as in the previous parts. So if you haven't watched those yet, I recommend checking them out first. You can also download the dataset we are using from the link below in description. Today we are going to explore some very important operations in Pandas, including how to sort values, group data by category, and perform both the simplex and complex aggregation. Those techniques are essential for anyone who wants to work with a large data set efficiently, whether for personal or professional project. Without further delay, let's jump and right into it. Let's start our first operation. Sorting by age. Sorting data is a fundamental operation when working with a data set. In this step, we are using the sort underscore values function to sort our data by the age column. Sorting helps you understand trends and organize data better, such as identifying the youngest or oldest individual in this case. Okay, by is equal to age. By default, sorting is done in ascending order, which means the smallest values come first. In the context of our dataset, people with the lowest age will appear at the top and those with the highest will be at the bottom. This is a useful way to quickly arrange data without modifying the original dataset. Next, sorting by age with in place function. Now let's take the sorting process a step further. In the previous step, we didn't modify the original data frame. We only displayed the sorted result. But what if we want to permanently apply the changes to our data set? We can achieve this by setting in place is equal to true. Let's write, just copy it, paste, and just we have to add in place is equal to true. This parameter ensures that the original data frame gets updated directly without creating a new variable. Run it. Okay, where is the error? Okay, just remove. Okay, run it again. This is particularly useful if you want to avoid keeping a track of multiple versions of your dataset, making your code more efficient and easier to maintain. Okay, great. Next, sorting by age in descending order. First, we have sorted in ascending. By default, it will be sorted in ascending. If we want to sort in descending, then we have to add one more thing. Sorting isn't always about the finding the smallest value. Sometimes you need to reverse. Maybe you are looking for the top salaries or oldest people in your data set. So by setting ascending is equal to false, we can reverse the order of sorting. Let's write, just copy it, paste it, and just we have to add one more thing, ascending is equal to false. This is a common requirement when we need to prioritize the largest value in dataset, such as showing the most senior employee in the company first. False. Run it. Okay, here we can see that 40, 35, 32, 33. Next, let's move to next step, grouping. Next, we are diving into one of the most powerful feature of Pandas, grouping. The group by function allows you to split the data into groups Apply a function to each groups and combine the result. Grouping by gender and counting all columns. We will first see the grouping function. In our data set, we have a male and female, two types of gender. So we will apply the function. We are grouping the data by gender. After the group by operation, we apply count to count non-null or non-missing entries for each column. Within each group, for instance, we can count how many people belong to each gender and how many valid entry exist in other column like salary or department. Dot count. Run it. Okay, here we can see that there are 4 female and 5 male. Okay, counted 1 2 3 4 5, right, and 4 female. Okay, 1 2 3 4. Okay, age, we have 1 female age available and 5 male. Okay, we can verify it. Okay, male 2 missing and female. Let's start our next operation, counting a name in group by. What if we only care about a specific column when grouping? Here we are grouping by gender again, but this time we are only counting the number of names for each gender. By selecting name after the group by operation, we are telling Pandas that we only want to focus on that column. Let's add some rows. Just copy this. Paste it. Just add name column. This gives us a simple count of how many individuals are in each gender group. Counting a specific column is especially helpful when you want to get a more targeted insight from your data. Here we can say that 4 female and 5 male. Okay, let's move to next. Aggregation with count of name and mean of salary. Okay, grouping data allows us to not only count but also perform multiple calculation across the different columns. This is where aggregation come into play. In this step we are using other function called .agg function to apply multiple aggregation. Let's write. We are counting the number of name entries for each gender, just like we did before. We are calculating the average salary for each gender group using the mean function. Write with me. Dot aggregate curly braces and add name colon count comma salary colon mean. Run it. The aggregation function is the game changer because it allows you to summarize your data in different ways, all at once, providing a deeper insight without needing to write multiple lines of code. Here we can see that we get salary of male and female and also name, count of the name. Next, complex aggregation with multiple function. Now let's move on the something more complex, performing multiple aggregation on different columns. In this step we are grouping by gender and applying a multiple aggregation function. Like, let's follow me. Just copy our previous code and paste it. Okay, we will add something like with salary we want mean as well as sum, so comma sum. Okay, let's add one more like age. We want age also in let's say mean and also in sum format. Mean and sum. Okay, good. Run it. Okay, we forget a comma, like comma. I think we forget comma. Yes, right over there. Run it. Okay, here we get our result: a count on the name column, a mean and sum on the salary column, a mean and sum on the age column as well. Okay, this type of multi-level aggregation is extremely powerful when you want to analyze data from various angles in one go. For instance, we not only get the average salary for each gender but also the total salary for all the individuals in the group. Similarly, we get both the average and the total age, which could be useful in determining the distribution of age across the different gender.